Hi everyone, Dr. Piantek here. I just want to take a quick overview of Chapter 12 of your Terry text. We are going to be talking about data analysis. So the objectives of this PowerPoint presentation is at the end of the presentation you'll be able to differentiate between descriptive and inferential statistics, discuss the use of a frequency distribution, describe the 3 measures of central tendency, describe the 4 levels of measurement, and describe the process with narrative and thematic analysis. So with descriptive statistics, we have univariate analysis and bivariate analysis. With univariate analysis, we're looking at one variable, whereas with bivariate, we're looking with 2 or more. So for the purpose of Chapter 12 in the Terry text, we're going to focus on univariate analysis. So part of descriptive statistics is looking at the distribution of your data. One area that we can look at is the frequency distribution. So if you noticed on this slide, I have a chart, or rather a table, that shows you one variable, which is the number of years as a registered nurse, and 2 groups of nurses. So there were 30 nurses in Group A that had indicated they had been a nurse for 0 to 5 years. This table is an example of the frequency distribution. And most of you with your DNP projects will be using some sort of frequency distribution or perhaps percentages when you're reporting your data. So with central tendency, there are 3 parts that we can use. We can use the means, we can look at the means, the averages rather. We can look at the median of the values as well as the mode of the reported values. Central tendency basically, in a nutshell, is an estimation of the center point of the distribution of your values. So again, the mean is the average of the group values, the median is the score that is exactly in the middle of the group values, and the mode is the score that occurs most frequently. So let's get into a little more detail. So if we have these 8 numbers and we want to calculate the mean, we'll simply add all the numbers together, which gives us 46, and we'll divide it by the total number of values, which is 8. So when we divide 46 by 8, we get 5.75. So our mean is 5.75. For the median, let's take the same 8 numbers, and we're going to reorder the numbers from least to greatest. As you see here, I have done just that. And then we're going to take the middle scores. And because we have an even number of values, we're going to take the 4th and the 5th of the total of the 8 values. We're going to add those together, which gives us 11, divide by 2, which gives us 5.5. So our median is 5.5. For the mode, we're going to take the same 8 values, and then we're going to simply list how many times the value occurs. So for example, the value of 7 only occurs once, the value of 5 occurs 3 times, the value of 6 occurs twice, and the values of 3 and 9 each occur 1 time. So our mode is 5, as there are more values of 5 than any other value. Next, we're going to talk about dispersion, and this refers to the spread of the values around the central tendency. There are 2 types, range and standard deviation. So to calculate the range, it's very simple. You're going to subtract the lowest value from the highest value. So if our highest value is 9 in our sequence of numbers, and our lowest value is 3, we subtract 3 from 9, which gives us 6. So therefore, 6 is our range. Now with the standard deviation, this is calculated by the distance between each value of the mean. Standard deviation is typically calculated using a software program such as SPSS. And so for the purpose of the DNP project, we're not expecting you to calculate standard deviation by hand. That would require a higher level of statistics. But if your study requires you to report the standard deviation, you can use a software program such as SPSS. So let's talk a little bit about the levels of measurement. There are 4 levels: nominal, ordinal, interval, and ratio. So with the nominal level, think categories. Examples of this are gender, smoking status, religion, anything that basically is not one better than the other or one higher than the other. So for example, if we take gender and we look at possible options to respond as male, female, gender neutral, or prefer not to answer, one option is not better than the other option. One option does not hold a higher value than the other option. Simply put, these are just categories. So when you are measuring the central tendency using nominal variables, you're going to use the mode. If you're measuring variability, you'll want to use the range, or perhaps you can do a frequency distribution. With ordinal data, these are responses that are ranked in a higher versus lower attributive category. So examples of this would be like a stage of change. If you're looking at where is a group of people who are smokers, where is each individual in terms of wanting to quit smoking? And so each of the options actually has a meaning behind it. Pre-contemplation, they have no desire to quit. Contemplation, they're thinking about quitting. And active is they're actually in the process of quitting smoking. So there's actually, like I said, there's meaning behind that. It's ranked higher versus lower as an attribute. So if you're using ordinal data, you're going to use the mode or median when you want to calculate the central tendency. And to measure variability, you'll look at the range or perhaps the frequency distribution. So using interval data, these are responses that are ranked on a scale with equal intervals. An example of this is if you use an instrument, for example, the Epidemiologic Studies Depression Scale. This is a 20-item scale with scores that can range from 0 to 60. And so a lot of your instruments that are Likert type scales will be interval. You can also think of age as interval as well if you are measuring the age of your participants. So when you are looking at central tendency, you can use the mean, median, or mode. And when you're looking at measure of variability, you can use the range or standard deviation. With a level of measurement using a ratio, these are responses that are ranked with equal intervals between the numbers on the scale, but there is a presence of an absolute zero. So if we think of weight, for example, there is an absolute zero, and as you begin to look at the intervals, you can always keep in the back of your mind that the scale is moving in the upward direction, but that absolute zero has to be there in order for it to be considered a ratio level of measurement. So when you're thinking about measuring the central tendency, you can use the mean, median, or mode with ratios, or if you're measuring variability, you can use the range or standard deviation. So let's talk briefly about inferential statistics. This is really important if you're wanting to draw conclusions, if you're wanting to say something is statistically significant, or if you want to estimate probability. So there are a couple of aspects that are necessary for analyzing data using inferential statistics. First of all, your sample used in your study must represent the larger population. Secondly, the level of measurement must be at the interval level. Responses, again, are ranked on a scale with equal intervals. So inferential statistics require the use of a software program such as SPSS. So one test that is used for measuring differences between groups is the t-test. So an example of this is comparing how long male and female patients with CHF attend a cardiac rehab program. So our two groups are males and females who have CHF who are attending a cardiac rehab program. And what we want to know is there a difference between male and females that do this? Well, you can certainly demonstrate the results by using a frequency distribution, or if you want to show statistical significance between the two groups, you would simply use a t-test. And again, that t-test can be completed through an SPSS package. Another example of a test used to measure inferential data, or when you want to take data and you want to show the statistical significance, is the analysis of variance, or the ANOVA test. The ANOVA analyzes the data of more than two groups or a measurement that is taken more than once. It examines the data to see if the group means are different. It also examines the variation present among all groups. An example of this is comparing the effectiveness of different interventions to help people stop smoking. So let's take a look at this in a little bit more detail. So when you're comparing the effectiveness of different interventions to help people stop smoking, we have three groups of people. We have a group of smokers who are receiving counseling through the nurse. We have group B, which they're receiving the nicotine patch. And finally, we have group C, which they are not receiving any kind of treatment. So the 28 represents the number of cigarettes that one of the participants in group A had smoked in the last month. In group B, the 0 represents one of the participants' amount of cigarettes that he or she smoked in the past month. And group C represents a participant's number of cigarettes that he or she smoked in the past month. So each one of these in group A represents a participant. Same with group B and group C. When we add up the numbers, and again, these numbers represent each participant's number of cigarettes that they have smoked in the last month. When we add these up and divide the number by 6, we get a mean of 28 for group A. When we look at group B and we add them up, the average number of cigarettes that are smoked are 15.33. And respectively for group C, the number of cigarettes smoked for that month for all participants was 49.16. Now with that said, this demonstrates, just looking at this chart and looking at the means, the frequency distribution. However, it does not tell us if there was a statistical difference between the groups, and that's where running an ANOVA analysis comes into play. So if you have ordinal data and you can't use a t-test and you cannot use an ANOVA, there are other statistical tests that can be run. So you have the chi-squared, you have the K-Smirnov, and the Mann-Whitney U. I won't go into great detail about this because typically DNP students will use percentages or frequencies to describe their data. But if you are going to be using inferential statistics, sorry, it's late in the day. If you are using those, you can always just reach out to me or to your chair, and we can go into further detail as far as how we would run that analysis. Okay, so I'm going to actually do our video in 2 parts. We're going to pick it up here in the next video and move on to qualitative research. I'll check back with you in just a sec.